Okay, welcome back. Today I got something different on my bench. A little exciting for me because I ordered this a while ago. Let me explain what this is. This is a Fluke 6080A. It's a synthesized RF signal generator. It goes from 500 kilohertz up to 1 gig. I was looking for a piece of gear like this so I can do alignments on AM/FM radios and other communication devices. But wow, this thing survived the trip. It's pretty beat up, and it's got a lot of damage. I don't know if the damage was from the shipping or if the seller misrepresented some of the damage. But like, for example, this knob's broken off. That's no big deal. But all the damage is mostly on the back and the case. I'll wrestle this thing around and show you. Just hang on. Alright, threw my back out yesterday shoveling snow, and this thing is just screaming at me now. So look at the back of this. It's all smashed. The fan is crooked, the lid is wonky here, transformer covers kicked in. What is this thing? Oh, my 10 megahertz output signals, BNC smashed. Oh, that one's still intact. That's a surprise. I might have a broken switch here, and yeah, it's not happy with this at all. I think the guy misrepresented his the listing on eBay. It showed some pictures, and it didn't show this unit. It showed another unit that had full handles on the back, and they were intact. These ones are smashed, and it showed the unit on eBay had feet. This one has no feet at all. They're missing. But wow. Okay. Let's. I don't want to plug it in because. Well, here first, let's go over this. This is his description in the eBay auction. It says, "Please read." Okay. This unit comes on and runs loudly, but no indicator lights come on. No other testing has been performed. It has scratches and marks as pictured. There is also a place on one corner where it is bent upwards. Yeah. Close-up taken of that. With limited testing and knowledge of the unit, is being sold as non-working and for parts repair and no returns. So yeah, I knew I was buying a dog, but I didn't know how bad it was. What the hell is that thing? But let's see. He says there's no lights or indication on the front, and it makes a loud noise when you power it on. Well, I'm guessing the fan is either busted or rubbing. That seems to be working. So maybe what we'll do is we'll turn it back around and we'll put some power to it and see what we get. Okay, I plugged it in. Okay, it was switched off. I plugged it in, and I could sense that it was drawing current, and I can hear humming, a faint humming coming from the unit. So it must be powered on all the time, and there is a light here. There's an amber LED in this bottom corner of this display. So it seems like we got power. Let's plug this thing in and see. Right. A noisy fan. But we got nothing on our display. So I'm guessing it's going to be a power supply repair. And God knows what else, eh? Does it have to wait for it to boot? I think I waited long enough. Okay, light's back on. Let's take the covers off and we'll check for voltages. Okay, so let's get the cover off. Let's hook up a voltmeter. the power supply is right here, and right on the top they have test points marked off. 37 volts, 15 volts, 24 volts. I think they're all here. We'll just turn this on and see what we got. So on the 37 volts, let's see what it reads. I have about 1.5 volt on the 37. That one's low. Which one is this one? I think this is 24. Yep, and that's reading good. That voltage is dead, whatever that one is. I can't even read it from here. There's some more here, but I can't access them with these cables in the way. This is supposed to be a linear supply. Okay, what do we got here? That's a negative voltage. The only one I got is plus 24. The rest of them are out. A couple more here. That one's dead. And another 24 volt. So that's all I got in this thing is 24 volts. The rest of the supplies are dead. Let's take a look at this. That's how you service it. It's got a gas shock. Thing weighs a ton. Just taking the back panel or back cover off, bottom cover. Sorry, just took the screws out. Now, yeah, looks like I'm going to have to do some hammer and dolly work on these. The sheet metal here is pretty beat up. It's just aluminum though. And this is all power supply, transformer, and empty space. So I'm going to have to fix this too. But this here, I'm going to see why we only have certain voltages. I'm assuming. I hope the transformer is not pooched, because if it is, I'm out of luck here. Looks like somebody unplugged this transformer connector. I was hoping I'd see some fuses here on the board, but I'm not. So I'll have to start disassembly and take this power supply out. Wow, look at this, is disconnected. That's on my output. Why would that be unhooked? There. Take that up. Somebody's been in here before, that's for sure. Alright. The power supply out. So if you pull the fan out, the fan's just mounted on these rubber bushings. Pull the fan out and you can get a squint in there, but you can't really do anything. So I'm just going to take the back cover off, back panel. It's all going to come off anyways, because I need to straighten all the sheet metal out. I'm going to straighten this and fix this connector. So yeah, there's a bunch of bent stuff back inside here too. So I'm going to have to get in there, and thankfully I don't think anything's been damaged beyond the point of no repair, but I don't know about that power transformer, if that's... I don't think it's touching inside there. I think it just got a good whack. But I'll take this all apart and see. I'm going to get this power supply out. Just before I go too far, I just want to check the power transformer, just to make sure I'm not flogging a dead horse here. So we got, looks like 1, 2, 3, 4, 5 different windings. So I'll check some of these out. That one's working. That one's about 7 volts AC, center tapped. Let's try this one. That one's working. What do I got there? About 15 volts AC, center tapped. Ooh, be careful. I like these, everything's gold plated connections on these. It's quality. What do we got here? We got about 43, 42 volts AC on that one. So far, they looks like they're all working. And that one is 29 volts AC. Be the last one. That one goes off scale. And we got roughly 36 or 38 on that last. Yeah, so all the windings are good. Problem is on this board. So let's tie into it. So yeah, thankfully this didn't damage this, because this would be irreplaceable. I'd have to find another one. This I can straighten out, but yeah, that's a good sign. Yeah, I'm kind of annoyed with the seller because they posted pictures of a different unit that didn't show damage, and this one clearly wasn't the same unit that was on the auction. Yeah, to me it doesn't really matter, because I know I paid a decent price for it, used, and I knew it was damaged, and I bought it with the full knowing that I was going to have to redo some kind of work to it to get it back running again. But I just wasn't pleased with the way he did that. You know, to somebody else that might have been a big thing, but you know, to me, I can work with it. Alright, so this is all the AC inputs here. I'll have to go through and check. I don't see any fusing on this, unless they're using fusible resistors. What has it got here? It's got, this is a 7824. That's a rectifier. This is a 7915, 7905. This one's it says Q1 on it, but it's also got 5 legs, so it must be some kind of regulator. Here's another one. It says Q2. It's got 5 legs, but it's RFB 18N. 10CS. I don't know what those chips are. I have to look them up. And we got the good old LM339 PMI OP471. I don't know if that's an op amp or a regulator or something. But we're going to have to dig into this deeper because I'm not seeing anything wrong with it. Here's another chip. CR999. Huh. I don't see any fusing on this. A couple of bridge rectifiers here. These black ones. Okay, well, time to break out the multimeter and start testing things. Okay, we're making some progress here. The manual for this signal generator is fantastic from Fluke. It's got a whole section devoted to just the power supply. It goes through everything, circuit description, got block diagrams for you, you know, how everything works, troubleshooting. So I went through this and I looked, and it said here, second last paragraph, troubleshooting. If the fan supply of 24 volts is on and the rest of the supplies, with the exception of the 23.4 and -5, are off, check the current limit circuitry. You know, a short at either the +15 or +5 could cause the current limit to trip and turn all the non-standby supplies off, with the exception of the fan, which is kind of what happened to me. Like, I turned it on and all I got was a fan, and then I checked the supplies, and you know, I had +24 and the rest of them seemed dead. So what I'm going to do is I took the supply out and I traced the pins from the test points back to the connector, and I determined that these yellow wires are +5 logic. The red wires are +15. So I'm going to inject 5 volts into the +5 and see if I have a dead short. I think that would be the quickest way of dealing with this. And of course I don't have my glasses with me, so I'm just going to do this blind. Actually, you know what? I need a pin. I'm going to get a pin and I'm going to go from there. Okay, so I got it. I got +5. I measured it on my voltmeter, and we're going to put it on. I got my regulated, okay, that's drawing 1.25 amps. .35 amps, 1.29 amps. Let's check this one. It seems high to me. Wow, I'm getting 2 amps out of this one. Two amps. 1.3 out of this one, 2 amps out of that one. That's 3.3 total. I don't know what the spec is on this. Okay, I'm going to set this up for +15 and I'll check that. Okay, make sure we get the right one. I don't want to blow this thing up. And 2 amps there. 2 amps. 2 amps. .690 milliamps. 690. You see smoke coming out anywhere? What I'm going to do is I'm going to try putting the power supply back in, and I'm going to try one of these at a time, because this plug supplies this sub-assembly with power, This plug supplies the top subassembly for power. So I'm going to try one at a time here, and if one of these is going into overcurrent, it'll shut down when I plug it in, independent of the other one. So I might have to open up one of these subassemblies to see what's going on with our power supply current draw. Alright, so I got everything connected back together. I got the AC input to the transformer is plugged into the power supply, and I have the connector for the lower assembly plugged into the power supply, and I have the sense cables from the signal cables from the front panel, the power switch. Let's plug this in. And let's turn it on. Now let's check for some voltages here. Yeah, we're still getting nothing. Okay, so let's disconnect the power. Let's remove this one. I have a feeling this short is in the plus 5 volts because it okay, plug that in, turn that off, plug this back in. Power back on. Check for some voltages. Still nothing. Okay. Let's check the supply on its own. Put this back in. Turn on. How am I going to do this? I'm still getting nothing here, so I'm guessing the supply needs some work. Okay, I dug up some data sheets for the parts on these boards. RFB 18N 10CS is actually a field effect transistor, enhancement mode power field effect transistor. And there's two of them on there, and they control the the plus 5.1. Q1 is on this line. This supply here feeds 5.1 logic, and there's a transistor sitting in there, and then there's also the U1 op amp. There's an op amp in there, comparator. And then the other field effect transistors in Q2, and it's sitting on this line, the plus 15. So I'm going to go through and see what voltages I have on these plus 5 and plus 15. And there's a return signal from the power switch on the front panel, the standby control. And that's the toggle to put this unit into standby and to wake it up. So I'm going to see what signals we have coming from the front panel. Okay, so plug this, plug this in and we'll get some power to the supply. I got the power transformer. Plugged in, so everything should be live now. What happened to my... Now, if this were a switch mode power supply, I wouldn't be touching it. It would, it could kill you. But we already have an isolation transformer here, and we're getting relatively low voltages. I think the highest voltage I measured on this was 55 volts. So I'm pretty much safe to pick this up and move it around. But I just wanted to make sure that you understand the difference between a linear power supply with isolated transformer and one that doesn't. Okay, so where are we here? One of these should be plus 24. I think that's the one there. Yeah, 24 volts. So this is the connection here. Pin 1, 2, 3, 4, 5, 6. Pin 6, pin 7. Getting anything on any of those. Okay. Turn the power switch on. Nothing. Nothing. Okay, that's off. That's on. So I guess when you turn it on, it breaks that. That's on. Okay, I gotta figure out where I want to check these transistors too. Where are we? Where'd they go? Oh. Pin 1's the gate. Pin 3, the drain. 5 is the source. Okay, so pin 1. How many volts is that? That's only 3 volts. Why is that? Okay. That's 10. Climbs very little. Pin 1 is the gate. Okay, something's going on with these op amps. I don't think it's telling the transistors what to do. We have our signal coming in here. It's a 24 volt standby signal. When I hit the power button, that kills that. There it is. It's on pin 12. What is pin 12? And then that's the 339. 339. 339. Pin 12 VCC. Why is that switched? Board is getting warm. I think it's just this 24-volt regulator. Yikes, I think I found my problem. This LM7905 is scorching, and there's actually no reason for it to be scorching. There's no load, and it's just, ow, burns my finger. So I'm going to replace that. LM7905. Yeah, I should have popped one of those in. So what I've done is I replaced that 7905 minus 5-volt regulator because before, when I was testing, this regulator got very hot. So I put a new regulator in there, a replacement one, not a new one, and I plugged it into the chassis, plugged in all the connectors, turned it on, and that regulator got hot again. So I'm thinking, what's going on here? It got hot when I had no load connected, but these were unplugged, and then it got hot when I had my load plugged in. And I was trying to look at this printed circuit board. The output pin is the one on the right, and I was trying to follow the traces, and I thought there was a little capacitor here, this green capacitor. You can see that. I thought it would maybe short it, so I took my ohmmeter, got in there and checked it, and it was 6.8K. Flip my leads around, 6.8K. I didn't see nothing, but I couldn't see any other traces going anywhere else until I went like this, and look at that tantalum behind there. I don't know if you can see it. It's failed tantalum capacitor, and I think that's on the output. So I'm going to replace that tantalum and see, and then I'm going to try it again and see if this regulator heats up under no load. Okay, so you won't believe this. I replaced this regulator, the 7905 minus 5 volts, and then I discovered that busted tantalum capacitor behind there, so I replaced it with a 10 microfarad electrolytic. Now look at this. You know, I'm disappointed in myself. I should have seen this the first time I looked it over. When you look at a board over, you look at everything, and you should have been able to spot that. I don't know why I didn't. I guess I'm just getting lazy. But that's a 100 ohm carbon resistor, and I'll have to change that next. So stay tuned. Okay, so I now have three parts replaced. The 7905, that blown up tantalum cap, I put it in a 10 microfarad electrolytic, and that carbon resistor that was burnt to ash, I replaced it with a 100 ohm flame proof resistor. So all that's left to do is plug this back together and do an initial test. Hopefully we got life on the machine. Okay. Either that or we're going to have a smoke show. Put in the power supply. Turn it on. And we still have nothing. Okay, time to give you a little update here, what's going on. I've been through this board over and over again, and I can't figure out, or I couldn't figure out what was going on. What happened was, when I put power from the secondaries into the supply, I had U5, which is a minus 5 volt regulator, overheating. And so I replaced the capacitor behind it, thinking it was shorted, and in hindsight I don't think it was. But there was also a resistor here, R29, that was burned out, so I replaced that one. So I figured I got the problem solved, replaced the regulator, and plugged it in, tried it with a load, didn't work. Tried it with no load, load removed, and this regulator is still overheating. And I'm like, why is that overheating? There's no load applied. It's disconnected. And then I started thinking, U5 isn't even part of this block diagram. So I was, what's U5? So I was reading through the text. Where is it here? There. The -5 local supply, U5, provides negative voltage to U1 and a -1.3 volt for U7 and U9, shut-off voltage. So I got to thinking, well, okay, so U5 only supplies this board with a negative rail for these op amps. So if this is overheating, it must be a short somewhere on this board. So I assumed that it was the op amp DOP 471, because when I did some voltage readings, I didn't get any voltages across this op amp at all. It was pretty much dead. No voltage swings when I did the power switch on off. So what I did is I removed this op amp and I tested it again, and sure enough, U5 was overheating. And I says, okay, well, this isn't funny anymore. So what I did is I got my VOM out and I started checking everything. I started checking diodes and I started checking capacitors. All the capacitors were fine until I got over on this side and I found a shorted capacitor. Another one of these tantalums shorted. So I replaced it with an electrolytic, put the op amp back into socket, and I'm now going to try it just to see where we are with regards to which one goes where. This one goes here. Just want to give it a try and see if the problem's been solved. I kind of have a feeling it is. And if not, we'll just have to keep looking. Okay, this power is off. I'll shut that off. Let's put this in. The secondary of the transformer. And then we have to plug in the power switch from the front panel. Okay. All I do is turn the power on the isolation transformer, cross my fingers, and hit the power button. And look at this. I have power now. It's working. So all it was that shorted tantalum, and I had a shorted or burned out resistor. So we got this power supply working. I can't leave this powered on because there's no fan, and it's going to start overheating. But the overcurrent protection was kicked in because of that shorted capacitor. And now that I replaced it with a 10 microfarad electrolytic. It'll be fine. It'll be fine. There's a fan blowing on this circuit continuously as it's operating. Everything in here, I checked all the caps, ESR and all the caps, everything's perfect. So, yeah, those damn tantalum capacitors are all over here. And that one was shorted, so okay, let's put it all back together and do some testing on this rig. I just want to say one of the things that made troubleshooting this board so difficult is that this power supply board is 4 layers. Let me pull this off. And there's layers embedded in the board, and to trace wires and figure out which goes where is damn near impossible. There's no schematic. They provide a block diagram and they provide a parts list. Parts list was helpful because it helped me identify that resistor that was burnt. But yeah, it was difficult to work on because there's 4 layers, and why does it need to be so complicated? I know that I understand they're trying to provide protection for the unit, but I don't know. I think they could have made it a little more easier. Put some fusing in here would have been better. Yeah, we're gonna get this all back together and give it a test. I have a feeling the rest of the unit is going to be fine, and I have a feeling that capacitor that shorted out put this thing out of service. So I shouldn't run into any more hiccups with regards to the signal generator itself. I think the power supply would have been the only one, and that was probably the deciding factor as why this machine was retired. So, okay, let's get it all back together and start playing with it. One last thing I want to do before I button this up is I wanted to take the front panel apart and clean the vacuum fluorescent tube and the inside bezel, because they usually get pretty grimy. It's got a screen on there, protective screen. I guess it's RFI shielding. But over time these get so filthy with dust. Yeah, it's kind of grimy. That's better. There's no way to clean this without removing that screen. Okay. Well, I'll just put it back together then. Oh yeah, and I added a knob. So I'll get this back together and then we can try it out. Okay, it's all back together. I got everything back. I straightened up the case a little bit. Mostly the back panel, the back panel with the fan housing and all that. That was all bent up, so I straightened that up, and it's a lot better now. And we determined the fault was a dead capacitor, tantalum. I changed 2 out. I think 1 is still good, but whatever. They're out. And a resistor that burned out, and a negative 5 volt regulator. I bet you this is still good. You know, because it was getting hot. Just because it gets hot doesn't mean it's faulty. It could be in current limiting mode, or it could be in thermal limiting mode. These things are short circuit proof. So if there's a short on the line, they dissipate the heat and if they start getting too hot, they claw back on the current going through, and the voltage drops. So that's probably a good one. But whatever, it's changed out. I still haven't decided what I'm doing with this BNC. This is my 10 megahertz reference signal out on the back from the crystal oven. I might look and see if I can find this piece or this connector on DigiKey or something like that. And I do not have this coax connector in my bench, so I'm going to have to rig something up here so that I can at least hook it up to my spectrum analyzer, and I'll see what kind of output I'm getting, and we'll do some testing to see if everything's working. But so far everything appears normal. There's no codes coming up, there's no error signals. You know, everything functions the way it looks like it should function. For modulation, let's see here, internal, you can set the modulation, and you can set the frequency, amplitude I can set, and you can hear the attenuator inside there switching as it goes through the ranges, up to 20 dB. Yeah. That's a lot. Status 0, 0. Okay. RF output. Turn that on and off. Sweep. So it appears everything's working. Of course, there's a learning curve with anything I pick up. $60 megahertz. $51. How come I can't go below 50 megahertz? Maybe there is something wrong with it, I don't know. Let's try this. No, because I had it at 1 megahertz before. There. Okay, turn this sweep off. There. We should be able to go down to 500 kilohertz. No, 10 kilohertz. Okay, I'm going to hook up something on the output here. Let's see what we got out of it. Alright, I'm feeding a signal into my spectrum analyzer. Right now I'm at 1050 megahertz. And as I sweep through I'll sweep down manually with the knob. And you can see how it goes down in amplitude and then jumps up again and then goes down. So right now I'm at 710 megahertz. There it drops again. See, right there is 610 megahertz. And it drops again. 510 megahertz. 410 megahertz it dropped. So it's every 100 megahertz I'm losing the strength of the signal. It seems like there might be something wrong with the signal generator. And I'm set at minus 20 dBm right now. There's a little spot right there, 610, up again, down again, 510. Every 100 megahertz there's a, this one here is at 400 megahertz. Down 80 megahertz, 70, 60, 20, 10. Yeah. Sweep function works. Here, I'll turn it on. It's working right now. I don't know how to set the parameters for sweep, so I'll have to read the manual. Modulation. Basically, I just wanted the thing for alignment of AM/FM tuners and receivers, and this will fit the bill nicely. It doesn't have to be super precise, or doesn't have to be bang on with its calibration either. And if I do some other RF equipment, you know, it's going to be good to have. But yeah, result. All right. Thanks for watching.